Welcome back to my YouTube channel. Today we'll be looking at expansion of function in a series of orthonormal function. Now, one of the many applications of orthonormal system is in series development of function defined within the same interval. So that is the interval at which the orthonormal function is defined. So let phi of n be an orthonormal function with respect to the weight function r of x on the interval a to b, and let f of x be an arbitrary function. It could be any function that depends on x. We wish to expand the function f of x is an infinite series of orthonormal function phi of n. So we assume a series of the form f of x equals summation n equals 1 to infinity cn phi of n. So when you want to expand the function in a series of orthonormal function, so this is how you write it. You say f of x is equals to summation n equals 1 to infinity cn and phi of n. So suppose this series exists. This series exists for f of x, so it means that f of x is already known because you'll be given, and phi of n is an orthonormal function which you get from solving a Sturm-Liouville problem. So the only thing that is needed to complete this expression is the cn. So you need to get the value of the constant. The cn is a constant, so you need to get the value of the constant. So to get the value of the constant, you will need to follow the following step. So let's solve for the value of the constant. So to do that, the first step is you will multiply both sides by phi of m and r of x. So phi of m is also an orthonormal function, and it is just one. It is like picking one orthonormal function from the set. This is a set now this is a set of functions, so we are picking one from it. We name it phi of m, and then this is the weight function. So we multiply both sides of this equation by phi of m and r of x. So if you do that, we get phi of x, phi of m, then r of x. So summation n equals 1 to infinity cn phi of n was there before, so just have phi of m then r of x. So after multiplying both sides by phi of m and r of x, so what we need to do next is to integrate. So we integrate with respect to x from the interval given, which is a to b. So if you do that, you have integral of a to b f of x phi of m r of x ds equals summation n runs from 1 to infinity integral of a to b cn phi of n of x phi of m of x r of x then dx. So if you bring out the cn, so you have summation n equals 1 to, so the cn is just a constant, so you can actually bring it out, and then you have a to b phi of n phi of m then r of x dx. So when you get to this point, what you need to do is very simple. Just say, since the phi of n, this set, this set is orthonormal system. This guy is an orthonormal system. What does it imply? It means that this integral, that is a to b phi of n phi of m r of x dx, this integral is equal to 0 when n is not equals to n, and is equals to 1 when n is equals to m is equal to n. So this is a summation, and this summation we have n equals 1, n equals 2, n equals 3, all the way to infinity. And I said before that the m is just a number, so if n could be 3, so if n is 3, it means that when n is 1, 1 is not equals to 3. When n is 2, 2 is not equals to 3. So at those points where n is different from n, this integral will just give you 0. But the point where it is just at a point that n will be equals to n, and as at that point this integral will give you 1. So because of that, our integral from a to b, f of x, phi of m, r of x dx now will be equals to cm, because we are now considering the point where m is equal to n, and then you get to 1, because that integral will give you 1. So at the end of the day, our cm is equal to this. Okay, so therefore the value of the constant is equal to integral of a to b, f of x, phi of m, r of x dx. So that is it. So see you in the next video. Thank you very much.